Okay, this is a video to help for Experiment 9. Experiment 9 is dealing with the ideal gas law. So if you, as you will figure out, the ideal gas law equals PV equals nRT, okay? T is the temperature. We like that in Kelvin. What that is how many degrees Celsius plus 273 to put it into Kelvin. R is the universal gas constant. That is what we are solving for. N is going to be the number of moles. So you're going to take your mass of your magnesium used and divide it by the molecular weight to get your number of moles. Okay, V is for volume. It's all going to be in milliliters, so please make sure that you convert into liters. And P is where you're going to see a large majority of your calculations. So we need to solve for P first, okay? So what we need is the absolute pressure. The absolute pressure is the atmospheric pressure, which equals the pressure of the hydrogen gas, plus the pressure due to the height difference in water, plus the pressure due to the water vapor in the air, okay? Easiest one here is the water vapor in the air. There's a graph that you were given, so you'll just follow over, find the temperature, go up, and you will determine what the pressure of the water vapor is. Now this is already in milligrams of mercury, so that does not need to be converted. As a constant rule for this equation, or for this experiment, be sure before you do any calculations that everything is converted into millimeters of mercury. Okay? Next, we have the pressure due to the height difference. Now, this is given to you in millimeters of water, not millimeters of mercury. So you need to convert the millimeters of water into millimeters of mercury. Now, 1 millimeter of mercury equals 13.6 millimeters of water. So what you're going to do is you're going to take your measurement of your height difference, which is in millimeters in water, and you're going to divide it by 13.6 so that you can get your pressure due to the height difference in millimeters of mercury, okay? Pressure of the hydrogen gas is what we're solving for, so let's look at the atmospheric pressure, okay? 1 inch of mercury equals 2.54 centimeters of mercury, okay? 1 centimeter of mercury equals 10 millimeters of mercury. So since we have to convert to millimeters of mercury, 1 inch of mercury equals 25.4 millimeters of mercury. So what you're going to do is you're going to take your atmospheric pressure that's given to you and you are going to multiply it by 25.4 so that you can get the pressure in millimeters of mercury, okay? Once you have all of these in millimeters of mercury, then what I would like you to do is rearrange it for the pressure due to the gas. That is going to be the atmospheric pressure minus the height difference minus the water vapor. Again, all of these must be in millimeters of mercury before you do the calculation, okay? Then what we need to do is we need to take that now that's in millimeters of mercury and we need to convert it to ATMs. 1 ATM equals 760 millimeters of mercury. So what you're going to do is you're going to take your pressure of your gas that's in millimeters of mercury and you're going to divide it by 760 millimeters of mercury to get that in ATM. Okay? Once that's in ATM, you will then plug that into P. Now, as you saw previously, we already know the volume. We're converting into milliliters. We'll have that. The number of moles, you know how to do that, and the temperature. Now we have P, so we can rearrange it for R. So R equals PV over NT. So your final result will be ATM times the volume, which in this case is liters. Okay, and it'll be moles times Kelvin down at the bottom. Okay, I hope this helps you guys.